All right, everybody. Thanks for coming out today, checking out the PLC to VFD live stream. So today we're going to be focusing on communications of a Compact Logix 5380 to a PowerFlex 525. We will be keeping this relatively simple and straightforward, just starting on the initial communications and the initial setup that we have. Nothing too in depth as far as programming structures or how to program it, but we will talk about a couple different options that you have as far as dealing with how to start off and how to set up your communications. We will just flip over here and talk a little bit about what we have going on. So like usual, we've got the desktop here. You'll see I have a few more icons on than last time. There's a few manuals that I'm going to want to walk you through a little bit. We'll talk a little bit about the term BootP and what BootP means and what DHCP means. As well, we're going to have a quick look at Connected Components Workshop as a value add to figuring out how to do communications with VFDs. Because Connected Components Workshop is actually quite handy in terms of setting up your communications and how things talk. There are some advantages to doing Connected Components Workshops. We'll talk a little bit about the PowerFlex 525 and some of the advantages that it has from that perspective. So again, want to welcome everybody for coming. Thanks for checking this out today. Yeah, and we'll get started here in a few minutes. I'm just going to let some stragglers come in if they're still interested in, and we'll kind of go from there. This is pretty much a standard setup as far as VFD communications go. There are some significant advantages to communicating over Ethernet IP versus communicating over discrete signals like digital inputs or digital outputs. So there are some pretty handy things that we can do, and we can set up, and we can configure by using Ethernet. Now, one of the obvious ones is that when you have more VFD devices, it's easier to see each one as they're on the network rather than walking over to each one and trying to use the HIM, the human interface, on the actual device to try to set up the actual devices themselves. So those are really nice for troubleshooting purposes and for seeing the way things work, but they're not super great for actually configuring. It would take a very, very long time. As always, please comment in the comment section. Let me know what's going on. If you have any questions or concerns as we're going through this. We will do later on, maybe in a few weeks, I'll do a little bit more of an in-depth live stream on the details, specifically how to maybe do a firmware upgrade on a 525, how to actually do some significant VFD programming, how to get into the nitty-gritty details. But today I really just wanted to cover how to set up that initial communications protocols and what we can really do from there. All right. So one thing that I did want to have a quick chat. So we've got our screens here. Everybody can see that. We'll flip over to the hardware real quick. We'll have a little discussion about what the hardware looks like. All right. So our hardware side of things. So today we will be dealing with more of the hardware on the VFD side. So today we still will be using our Compact Logix L306 ERM. So here you can see that I'm communicating over USB with that. We also have the Ethernet communications set up. So the Ethernet communications goes to our hub, right? So this is our hub where we're able to allow multiple devices to communicate together. You'll see over here we also have the PowerFlex 525. So the PowerFlex 525, this one is a single phase to three phase output VFD. Does about a half horsepower on the single phase, on the three phase output side. So it's not a very strong VFD, but it's very handy for doing demos and setups like this. You'll see here that we've got the actual screen here where we can do our setups. We've got a bunch of cursors and buttons over here you'll see me use in a little bit. Some fault lights, some push buttons, and some manual adjustments. Now underneath here, we'll pull off the actual cover, and you can see some of the setup underneath, right? So we've got our power coming in at the very bottom. We've got our digital inputs, digital outputs all connected here. You'll see we've got the safeties jumpered. We're not talking about VFD safety at this point. Definitely we can cover that in a later live stream, but at this point, we're simply just talking about how to communicate between the PLC. I have the Ethernet IP communication port, as well as the DSI. Now the DSI port is more based on serial communications, and there's specific DSI protocols that we can set up and use. At this point, we're not using that. We are going to go Ethernet IP. One of the advantages to the 525 is that it does have Ethernet IP embedded, right? So this is part of the standard package that you get with it. There's nothing different. You can get DLR or device level ring setups if you want to for the 525. And the 527, which is the one model up from the 525, actually has the ability to do safety over Ethernet, which is very interesting. Safety over Ethernet is very much like safety PLCs. Sometimes it's hard for people to get on board with that and really understand the values of that, because they're still a little bit old school, a little old mindset. So what we're trying to do is really change that mindset, change that idea here, where we can do safety over Ethernet. It is very much rated for those applications. Let's go back to the main screen here. We'll have a little chat as we go. So a couple things that I want to draw your attention to right off the bat. We've got Studio 5000, which we will be using. That is your basic PLC software. This is how we want to program, how we want to set things up. So that's your key software package. Connected Components Workshop, as I said before, it's more of a configuration software for drives. So we can use that to really set up and program drives. Now, Connected Components Workshop also allows you to program other versions of PLCs, like the Micro 850. So the Micro 850 is actually a PLC designed to be programmed by Connected Components Workshop. The advantage to Connected Components Workshop is it's free. So everybody can download that. Just got to log into the Rockwell website and download Connected Components Workshop. And you can kind of play around with that, look at the different configurations and drive setups and different things like that. The next thing is the BootP or DHCP tool. We'll talk about what BootP and DHCP tool is as we get into configurations here. Depending on where you work, some people will gravitate towards using a BootP tool. There are different devices in industry that you need to use BootP tools for to actually find the MAC IDs and understand what's out there, and then be able to configure and reset that. So the BootP DHCP tools are very, very handy as far as networking troubleshooting on Ethernet IP devices go. You'll see I have a few manuals here. I'm a huge proponent of using manuals to do troubleshooting. Most of the students in my classes know that that's very important. It is one of the essential skills. If you can't navigate a document to understand how to look things up, you're going to be in a lot of trouble when it comes to working in the field. Whether that's in any of the skilled trades like we train, or in the mechatronics, automation, engineering fields, if you don't know how to navigate a manual, if you don't know how to absorb that information, you're going to struggle. And that struggle is going to inhibit your growth as a person. So it's very important to practice using manuals, to practice using documents to try to pull out information and understand what we're looking at. Of the manuals that we have here, the first one is the QS manual, so the 520 QS manual. This is what we classify as the QuickStart manual. This QuickStart manual is extremely helpful in getting your drive. It's only 38 pages long. Seems like a lot, but when you look at the other manuals, you'll see why it's not. This manual really covers all of the QuickStart information that you need to know. How to mount, what kind of clearances are required for all your drives, how to set up all your brakes, the grounding, the power, all that needs to be set up there. All the fuses and circuit breakers that are required for setting all this up. So all of this stuff is really covered in the manual, and typically is covered in classes as we do the wiring for those. But there are certain things that we need to talk about when it comes to actually configuring the drive. How you navigate that HIM on the front is all covered in the QuickStart guide as well, right? We can see here that you've got what each of the letters mean, how to navigate all the different areas using the up, down, escape, start, enters, all of those things you can see there, along with the display LEDs. What do those display LEDs mean? How do we troubleshoot using those, and how do we understand what's happening there? It's even got a nice walkthrough on how to navigate from the basic screen, like you see in the hardware, all the way through each of the different steps to change what parameter group you're looking at, what individual parameter, how to adjust the parameter, and how to get your way all the way back to the parameters to change the next one that you're looking for. And then we start into the list of parameters. Now these are in the Quick Start guide is a very truncated small amount of information in the display parameters, or sorry, in the group parameters here. There are tons more. They're just kind of giving you those basic ones that you need to look at, how to set your basic drive, how to do your current outputs. All of those things are kind of covered in here. Make sure when you're doing any of the smart startup and the basic programming under P that you have stopped the drive, right? So they call out which ones need to be stopped in order to change on the drive. You can change some of these parameters live as you need to go. So you want to make sure that you're keeping your eyes on that. Advanced programming group parameters are all here as well. So these are more advanced things where you get into like your DC brake, how to configure your dynamic braking resistor, how to set your brake levels, how to change acceleration times on multiple groups. All those things are covered here in the advanced parameters. And then we get down to fault codes. So fault codes here are next, which are really important. When you start setting up your drive and you're starting to do your configurations, you want to have a quick group or quick lookup of any of the fault codes that happen when you're trying to configure that drive. So this is really just the Quick Start guide, right? Gives you a bunch of that basic information, some good handy things there. Now the next guide that we have, or the next user manual that we typically use is the actual full-on user manual for the 520 series frequency drives. Now you'll see this is significantly more pages. We're talking 274 pages for this manual. But this is an all-inclusive manual. So if you have this one, you don't necessarily need the Quick Start guide, although you have to spend a lot more time looking through this one to find out the issues that you may have. So here we've got section 1, which covers all of your installation and wiring, like we talked about before. Startup, how to actually prepare the drive for startup and what you do. Programming all of your parameters, right? How to set up your parameters, screenshots, how to use connected components Workbench to actually set up your parameters. And then you can start to see all the different options that you have in all the different areas of the programming parameters that we can look at and adjust. They also have a nice troubleshooting guide here. So if their faults do come up, if there's any issues with trying to start your drive, you can see all that stuff here. There is an auto restart sequence. And then we get into some of the more basic, more advanced techniques. So here you see the accessories, right? What other accessories can you buy for the drives? How do we set those up? The RS485, how do we do communications over RS485? Right? How that type of serial communications, how do we set that up? That's the DSI protocols. How do we do velocity step logics, basic logics, timer counter functions? These drives are pretty advanced where you can actually take that information that you have and that we normally do in a PLC, and you could do it in the drive. Now, I don't suggest that. I don't condone that. It's much easier to troubleshoot things that are in the PLC. So for me, it's a much better avenue to put all of that information in the PLC and have that transferred over to the drive itself. But you do have the capability of doing some of those steps, for step 1, running in reverse, and then running slower in reverse, then going forward, then moving faster. All of these steps that you can kind of see here, you have that ability to do that step logic in the VFD itself. See here, we can also incorporate an encoder, right? So we can take the encoder and pulse train and put that right into the VFD. So the VFD can take care of all that encoder information and feedback. So now you're turning this VFD into a little bit more of a servo-driven system, right? Where it is now more closed loop, where we can take that information, instead of just being open loop, where we send it to the drive, we let the drive run, we let the motor turn, and we assume it's doing what we ask it to do. There's no real feedback. Well, taking this encoder pulse train and how to do that for step logic, we can actually bring that right back to the VFD itself and close that loop off to understand how that works. We can do PIDs, right? So proportional integral derivative control. We can do that inside of this drive itself instead of being in the PLC. Well, the PLC and exclusive controllers and specialized controllers are a little bit better at doing that. So I would suggest maybe still doing that on that side rather than worrying so much about putting that into the drive. But understand that if you need some kind of standalone system, this drive can do a lot of this control itself. We do have safe torque off functions, which are the safety features on this. So when you get into safety wiring, or if we cover that later, you'll be able to see that under there. Ethernet IP, how to establish connections with Ethernet IP. This is obviously going to be very important for us. You'll see it's only a couple pages long, but there's some really good information under there as well, right? So there's some ability for us to actually pull up that information from the manual itself and understand how those basic functions work. And we can also do control diagrams. Let me just zoom back out. So you can actually do your motor configurations inside your control diagrams. You can see how adjusting the parameters would work, how we can make kind of predetermined, pre-set up parameters inside these control diagrams, and then actually configure the motor itself, how to download different files. All that's covered here inside that user manual. So the user manual is very, very important for us to be able to do all of those basic configurations. Now, the last manual that I have here is about how to actually use the embedded Ethernet IP adapter, right? So we just covered a 38-page quick start. We had a 247-page user manual, and now we have a 166-page Ethernet IP manual. So you can see there's tons of information, tons of things that you can do and set up, far more than I'm going to try to teach you here in the next 20 minutes, half an hour, on how to actually set these drives up. But we will break these out into smaller live streams so you're able to kind of see how, from the basic setup, how we move to, the more advanced setups, how we do some programming, maybe even to get into some multi-drive modes, right, where we can actually connect multiple drives up and have a master drive controlling some smaller drives. A lot of flexibility, a lot of configurations that you can do on these drives. So we'll start getting started with the basic programming, and then if you want to see some more, please let me know in the chat what you're interested in seeing and how and what that is, or what you're looking for more training. All right, so right off the bat, we're going to go over to the hardware screen itself. And from the hardware screen, we're going to talk a little bit about how to configure that drive. Like, how do we actually set up the drive itself to be able to see the different configurations and the different parameters that we need to see. Because there's a lot of different things that you need to look at on the drive itself before you can even get started talking about the actual PLC setup. So, first thing we have to do is remember how to navigate these actual lights and buttons, right? So from here, we actually need to go online here and change some of the parameters that we have. So to get to our parameter menus, you hit escape. Escape will bring you to your first menu, and we're actually going to want to change the values that we see here, right? So we want to be not in the B mode, which is your basic parameters and your basic functions. We actually want to be into the C's. The C's stand for communication. So communication is kind of that first area where you want to set up your settings. So the one we need to look at first, as far as setting up your communications, is we need to look at address C128. So if we look in our manual and we look up what C128 is, C128 actually is our address selector. So is our address going to be selected from BootP, or is it going to be selected from the parameters? So for us, we want to change it. The default for this parameter is to be BootP, which is option number 2. So if I change this to option number 2 would be what we would have this as default. As you can see scrolling across here, it says BootP. Now that's not ideal. We don't want this to be in BootP because BootP means that we have to find it on the network. We actually want to set this to parameter number 1. Parameter number 1 is for parameters. This allows us to hard code the IP address for this device inside of the actual parameter setup themselves. And conveniently, right after setting C128, which is how we're going to configure this, we can actually go into C129 and hit enter. And C129 gives us our first octet of our IP address. So as you could tell from the last live streams, we're going to use 192.168.1 because that's a nice private network for us. We don't have to worry about too much interference. And from this perspective, we're going to leave this the same way. So this is going to be 192, right? We can change that if we wanted to, hitting select. We can move the cursors up. We can move the cursors down. You can set whatever IP address you want in order to make that happen. So we're going to leave that at 2, 1, and 9, right? We're going to go back. We're going to go to C130. C130 is set to 168. That's good. C131, we're going to look at that. That's set to 1. Perfect. So now we have that set to our private addresses. We're going to check C132 now. C132 is that last octet. That's the octet that we really care about because we can't have it be the same as anything else on the network, because if it is, there won't be any communication on that. So in this particular case, we're going to leave this one set at 5. Right? You can have that set to whatever the address is, whatever address you need in your system, that can be set to that. But for our purposes today, we're going to leave this at 5. Now, when you get into 133, 133 is what we call the subnet mask. It's very important to set your subnet mask. So again, 133 is your first octet, 134 is your second octet, and 135 is your third octet. So those are important. You need to make sure that you match your subnet mask for what you have on your network and your network configuration. Typically, for private networks and most of the networks that we deal with, you're going to leave your subnet at 255.255.255.0. Right? So that's going to give you that basic subnet to allow us to communicate with our PLC, because that's what we have configured on our PLC side. So I'm going to get out of this now. We are going to move back to looking at our PLC now. So up here, I don't know if it's super noticeable, it's a little glary, but you can see on the scrolling window that we have this PLC set to 192.168.1.1. So we know we have this PLC set to one IP address, this PLC set to a second IP address. So those IP address settings, that's typically the way you would do most installations. There are other ways, and we'll talk about those here shortly, but that is the most common way. Once the drive gets powered up, you can actually configure that, right on the HIM itself. Now, if we go back here to our screen, we'll talk about a couple of the other ways. If you put this on the network and you didn't assign it an address, you can run this program called BootP. Now, BootP allows us to commission devices on a network and look for different communication setups throughout our current Ethernet IP setup. So this is what the commissioning tool looks like. So the commissioning tool has an area up here where it's doing a discovery. So currently it's listening for connected devices. And this can take quite a while. You have to just leave your BootP up and running. Eventually what you'll see is devices start to show up here with different MAC IDs. There's no IP address associated with them, or there may not be an IP address associated with them, but a MAC ID will show up. Once you find that MAC ID, you can enter a relation which allows you to assign an address. So if somebody's connected a device onto the network and you don't have access to the HIM to be able to make those manual changes, you could run this BootP Ethernet IP tool. The problem with this BootP tool is that you also have to be on the network. You have to have your laptop configured that way. You have to have your Ethernet IP addresses all configured in your control panel. And then you can run this BootP commissioning tool. So if that's something you're interested in more, I can run a BootP live stream later on. But this is one of the other methods that you can use to configure your BootP setup. So you can save your setups, you can save your IP addresses, you can do all of the relations, you can enable and disable BootP on specific devices. There's lots of different things that you can do in order to set up your BootP devices. Now, one of the things we're going to look at right now is because we've set up our device, right? We've configured our device, we've given it an IP address on the HIM. We're going to go see if we can actually see that in our RS links configuration. This is your first indicator that something is either working or not working. Right, so I have my current Ethernet IP-2 driver set up. So if I actually look at the driver configurations, you can see that I'm using my USB Ethernet adapter. I've given it the IP address. So the IP address of my computer is 192.168.110. So that allows me to join the network over there. And again, that last octet cannot be the same as anything else on your network. So if I actually go into this tool, you can see that I have three things running, right? I have my RS Links desktop, which is a virtual drivers, which is my laptop itself. I also have the PLC, which I can see no problem, and I have my PowerFlex 525 drive. So you can see that based on that configuration, I'm able to see both of the devices that I want to communicate to each other. So this is a very good indicator that something is going to work, right? That we're going to be able to make these things talk together. Another advantage is it actually gives us a little bit of information about the PowerFlex drive itself, right? It's a 525 single phase 110 drive, half horsepower. Now, if you right click on the drive itself, you can actually look at the device properties. So from the device properties, we can actually pull out the serial number, the revision, product code, types, all that stuff here you can see, and if there's any ongoing faults on the drive right from RS Links. Now you may see that the revision of this drive is pretty old. I'm doing another live stream where we're going to actually do a firmware upgrade on this one, so I've left this down at revision 1. And then we have our actual PLC here as well, right? We can do the same thing. We can go to drive properties. We can see that our revision drive is 30, or our revision of our PLC is version 30. We can see the serial numbers, a whole bunch of information about that actual PLC in here as well. Now the revision codes of our drive and PLC don't have to match. There's no requirement for that. They do firmware upgrades at different states and at different times. So we don't have to worry about those actually being the same or have any correlation between those at all. Now you'll see we also have our USB driver. So if I flip into the USB driver, I can see my PLCs on there, which is good. If you opened up your PLC, you can see a bunch of different things. Your Ethernet port, your other Ethernet port, what's on your backplane. Again, in this particular case, I'm not running any I/O cards because that's not important for what we're trying to showcase today. So we'll close down RS Links, and at this point, we're going to open up Studio 5000. So for Studio 5000, again, we're going to make a new project, right? Because at this point, we want to set up our VFD drive. So from here, we are going to make our new PLC, which is our 5069 L306 ERM. Just happens to be the one that I'm using. Again, doesn't really matter what PLC you're using as long as you pick the proper one. We're going to call this VFD test. We're going to make sure that the vision of our PLC matches the version of our actual program, because that's important. We're not going to put any securities or any type of permissions on that PLC. So we're going to let this PLC start up. Once our software actually loads up, we'll go through and make sure that we've got this set up the way we want it. Make sure that we can see all of the information. Again, if you have any comments or questions, please make sure you're putting those in the comments section. I'll be back always to check on those, answer any questions that you have as we go along. There will be time at the end as well for any questions or concerns. We will cover those off as we get to them. Apparently the software is taking a little while this morning. That's okay. There we go. So now we'll check over here. We've got our controller name, which is perfect. We check up at the top to make sure that we pick the right processor. This is an L306 ERM version 30. So that's good, right? We've got that right up here at the top. And now we have to go down here to our Ethernet controllers, right? We need to set up our system to ensure that we are actually talking the right talk. So a couple things that we can do, we can look at the properties, but again, we need to be online in order to change any of our Internet Protocol properties. Um, so what we can do is we can actually just go online right now. We'll go over to the USB, go to our actual device, and we're going to download that to our device. So once we download this current VFD program, we will actually be able to set up our Ethernet IP. Sure, we'll put it back into run mode. All right, so now we can set up our Ethernet IP settings. So we look here, we've got a port A. We definitely want this to be manually configured. We look at the current setup. The IP address is 192.168.1.1, and our subnet mask is 255.255.255.0. So that looks all good to me. That's kind of the settings that we want to use for this particular case. And so we're going to hit OK on that. Now we know that now our PLC is on the same network as our drive itself. Now from here, we can add a new module. Right? We can look for the PowerFlex 525. So this, again, if I look back here, you'll see there's a huge list of stuff that's in here. Some of them are grayed out. Some of them are not grayed out. There's a reason for that, because some of these can be added online and other ones cannot. So in this particular case, we're looking for a PowerFlex 525, so I just use the keyword 525. It's able to bring up the 4 that we have available to us. So we have the 525 via a 22COM-E. Now the 22COM-E is an extra module that you would actually install into the PowerFlex 525. You also have the PowerFlex 525 via E2P, which is another adapter. You have embedded Ethernet, which is the one that obviously we're going to use. And we have a multi-drive via embedded Ethernet. So are we going to use this as the master to control multiple drives over your serial communications? That's what the embedded the multi-drive via embedded Ethernet would be. So for us, what we really care about at this point is the embedded Ethernet. So we're going to click on that and we're going to hit create. So this is going to start to look a little bit familiar, hopefully, as far as creating a new module goes. We have the new module show up. At this point, we have to give it a name, look at the module definitions, pick the Ethernet addressing. All of that stuff needs to happen right from in here. So in this particular case, I'm just going to call this PF525. Right? We'll keep that nice and simple. We know that the IP address of this drive is 192.168.1, and we are going to put a 5 in there because that's what we manually set up on that drive on the right-hand side. From here, we also need to update and change our module definition. So if you remember, one of the important things that we saw in the RS links was the revision number. Now the revision number of this PLC is revision number 1. So you have to make sure that this revision matches the drive that you're using, because without that, there won't be able to have the communications. As we do firmware updates, things change and things need to be updated. So you want to make sure that your revision number matches here. Now, this is the proper drive rating for our drive, but more often than not, you're actually going to have to go in here and find the appropriate drive. So you can see there's tons of different drives in here. You got a single horsepower, 1 horsepower, or sorry, single phase 1 horsepower, single phase 1.5 horsepower, all the way up to 3 phase 30 horsepower, right? So we can configure all of our drives in here. So you got 3 phase 600, 3 phase 460, all of those things can be set up in here. And then you have electronic keying. Do we need it to be an exact match, a compatible match, or disabled keying, right? So we're going to use compatible module because we just want them to make sure that they're compatible, even if they're not exactly the same. This kind of allows us a little bit of flexibility. Now over here, you're going to see 2 other columns. We have an input data and an output data. What input data and output data are used for is to actually be able to drive and take over some of the data that exists inside of these drives and bring it to the PLC, right? So input to the PLC. We're also able to send out certain information out to the drive itself. So we call that output data. At this point, we're not going to cover all of the many options that you have there. We'll do that in a subsequent programming Ethernet IP VFD live stream. But right now, just understand that those input data and output data are how we can share that information between the PLC and the drive. We also have a mode select. Are we doing positioning? So this is more like a servo application. Are we actually using this drive to position something specific locations, or are we using this as a velocity? Now, most of the time you're going to use this as a velocity. The only time you would ever use this as a position is if you had an encoder built into it and you're looking for that encoder to provide specific feedback location of where it is, right? If that's the absolute application of this. Now, we can still use velocity as a position-based system, right? We can still say, listen, move forward at 20 hertz until you hit a proxy, then slow down to 5 hertz till you hit another proxy, and then stop. In theory, that's same as positioning, but it's not like a servo positioning where we're using encoders to drive our system. So you want to make sure that your mode select matches whatever it is that you want. From there, you hit OK. It's going to give you a warning saying that it's going to change the data types and the properties. Are you sure you want to do that? We're going to hit yes. And then we're going to verify that everything here is set up the way we want it to be. And we're going to hit OK. It's going to say, are you sure you want to create this online? You know, if you create this live and online, you may have some issues. So are you sure you want to do that? Normally in industry, we wouldn't want to create these online. You know, you don't want something to arbitrarily move or be adjusted. So you would want to do this as an offline process, add all these devices, and then download them. But this is just a simple way to add this module online into our current system. So now you can see that we have the 525 over here added to our project tree, and it currently says our status is running, so that's good shape. So let's go look at the properties of this device. So a couple things when we look in here, we can see all the parameters that we set up before, right? We have our revision numbers, we have our parameters, we have our modes. All of those things are actually set up here for us. We can see that we have our IP address set up, which is matching the IP address of our drive. If we go over to connections, we see there's no faults, right? We've still got that requested packet interval that we talked about before. How fast are we sending communications back and forth? Right now we're set to 20 milliseconds, so that's good for us. We can pull up the module information, right? The module information here tells us all of the information that we have on this drive. We've got the serial number, revision code. It looks a lot similar to what we have in RS links, right? We've got our module identity matching. It's, you know, are we in run mode? What's the status of this device? We can then look at the port conditions. Now the port conditions are using the module address. So if we actually were to look, we can see that we have the actual module address used by the controller is set right here. So the drive parameters are not being used. And then we have this drive section. So the drive section allows us to communicate with the drive. So it says there's differences found between our project and the drive itself. How would you like to proceed? Right? So we have upload, we have download, and we have show differences. So if we click on show differences, we can have a look here and say, what are the actual differences between the drives and the setup? So you can see that there's a whole bunch of information between the source and the target, which is what we want to do, right? How is the setup? So our target, which is our drive itself, currently has this information in it. And our source, which is our PLC, currently has this information for the drive. So in this particular case, we actually want to take what's in the drive itself and bring it to us. So we want to upload that information, right? So now we have the actual drive itself. I'm going to make this a little bit bigger so we can see more information. So this is still under the module properties of the drive itself. You can see that we're connected over Ethernet. There's the information. We can upload, you know, or download to the device. We can upload from the device. There's a whole bunch of things that you can see here. So in this first window, let's talk about that. We've got the series of the drive. We've got the revision number of the drive. Is the drive stopped, ready? What's the information going on in the drive itself? All that can be seen there, and the feedback. So currently, what is the actual frequency that it's running? So this is all in that first window here. Now the next one here is called ADC. Now ADC is a very cool feature that Alan Bradley and Rockwell have input into their software. What ADC allows us to do is an automatic device configuration. So we can actually store all the device parameters inside the PLC itself. And so if a drive goes down for any reason, we're able to take and update just the IP address on the drive, add it back to the network, and as long as that drive is compatible with what we've stored before in the PLC, we're actually able to dump those parameters from the PLC and push those into the drive. So that makes the maintenance of VFDs a lot easier. So if a VFD were to break or blow up or become non-functional in any way, all you would have to do is basically set the IP address up on the new drive, plug your Ethernet cable back in, and plop that back into the system. From there, the PLC would dump all of the information that it had stored for that IP address and that drive and that compatibility back into the drive itself. So that's a huge advantage to us. Now, device compare, we can compare the information that we have here back to the actual device itself. We also have the parameters list, properties of the drive, wizards, which we'll talk about in a second, faults. We can reset the device right from here. And this is one of the most handy things that they've inputted into this is the actual manuals themselves. So just like I talked about before about all the manuals that I like to use to have access to, they've actually embedded the manuals into this screen. So if you need the user manual or the Ethernet IP manual, or you need to look something up, they are built into this actual parameters sheet themselves. So it's very, very handy from that perspective. We'll work our way back. Reset's pretty self-obvious. Faults, you can see the last faults, right? These were the last faults that were on there. We had a safety open, under voltage because I powered it down, and an ENET loss because we were configuring those different IP addresses. So that's really important to see those last previous faults. You can clear the faults from here. You can clear the fault queue if you want to, right? So now there's no faults on there. You can clear the faults from here. All that stuff's available. A nice little feature they have as well is to be able to print those faults out. So if you need to print those faults or get that fault information, you're able to do that right from there as well. This is another very handy thing that they have is a built-in wizard. So these wizards are extremely helpful for setting up the basic functionality of a PowerFlex 525. They have what's called a startup wizard, which is one of the easiest ones. If you wanted to get into an application specific, you could do step logic velocity or step logic position. You can even get into some diagnostic wizards if you want to set up some other things. But for right now, we're just going to have a quick look at the 525 startup wizard. The 525 startup wizard has a whole bunch of information here that they'll just walk you through. Right? So you're able to actually step through each one of these parameters. Reset the parameters. Do you want to delete all the parameters that exist on the system? Yes, no. Reset all the factories, whatever you want to do. From there, you move on. Do you want this in English or French or Turkish? You can actually set up your language from here. You can go to the next and actually set up your motor control. What kind of torque motor are you going to use? Voltage per hertz, SVC, economizer. What are you going to use to actually do your torque performance mode? What kind of boost? What's the maximum voltage? Is there motor feedback? Yes or no, right? Are we using an encoder? Is it a single check? Is it pulse training? What are we using? We get into the next one where we actually set up the motor data. Here you can set up the number of poles, the FLA, the overload currents. All of the information for the motor itself can be set up right here in this wizard. We can get into feedback. Again, what are we using? Are we using pulse train? Or are we using quadrature? Is it using the encoder pulses? What is that value? All of those things can be set up in the motor feedback. And then we get into stop and brake. Are we using a dynamic braking resistor? What type of stop are we doing? Are we ramping or coasting or using a DC brake? Or are we using a ramp plus brakes? Like, how do we want to slow this motor down when it's actually running? From here, got a bit of an error there. It looks like we've errored out some of the issues that we have with our Rockwell software, but that's okay. We'll carry on. The actual direction test is a very handy little feature. So as you've walked through all of this wizards, they get to a point where they're like, okay, listen, we've got enough information now. Let us actually test your motor. So what you're able to do in this particular case, normally if you had a motor setup, which I do not, I only have the VFD set up, you would actually be able to jog your motor to different speeds. Now it's extremely important that you understand how your motor is currently set up and configured because you do not want this to be set up or attached to any kind of mechanical system. You want this to be a free running motor so that you can do the best information you can, knowing or checking to see which rotation you're actually running this in. Are you running this in forward, or are you running this in reverse? Right? We have the ability to do an auto tune. An auto tune actually takes all the information. Looks like I'm going to get a bunch of these errors today. A bunch of this information from the actual motor itself, where we can tune the drive parameters to match the type of motor. It's actually a very handy feature to be able to do some static tuning and some rotate tunes. Basically, what this does is it saturates the motor, looks for feedback on the lines. It does an IR voltage drop. It does some flux calculations on the current. So it's able to take a lot of that information from the motor and kind of optimize the setups from that. Here you can set the ramp rates and the actual speed limits, right? So how do you want the motor to ramp up? What's the maximum frequency you want that to run? And how do you want that motor to decelerate? Speed control, who do you want to control the speed? Ethernet IP? Do you want it to be over an analog signal? Do you want that to be, we can have up to 3 different speed references we're able to do. Ethernet IP, which is obviously what we're here to do. How do you want that configured and set up? Digital inputs, right? How do you want those digital inputs wired if you're using those? Relay outputs, optical outputs, analog outputs, and then it says, do you want to actually download those to the PLC? Right? So we didn't do any of those things, so we're just going to close this off because we don't want to actually download any of those parameters. But the wizard is extremely helpful for setting that up, and that's one of the advantages to having this configured over Ethernet IP is that we can have access to all of this information at that point. Parameters is very straightforward. This is where we have our communications, some simple import exports. You can actually save everything if you want to export the data. You can export this node's specific information and save that as a backup, which is always good to do, especially in the maintenance field. When we're in skilled trades, we always want to keep backups in case things fail. There's nothing worse than having a motor fail at 1 o'clock in the morning and having to manually rewrite all of the data because somebody didn't do a backup properly. And one of the last things I want to cover on here is the actual parameters itself. So the parameters of the motor are pretty extensive. You can see here we have parameter number 1 all the way down to parameter 731. And if I move this so you can actually see that, then it's much easier. So parameter 731 is the parameter, the top end, all the way down to 1. Now, this is pretty daunting. You're not going to be going through this and looking at each one of these and trying to figure out all the information. That's why the wizard is very helpful. Like the wizard actually breaks that down. Now, another way to actually break this down even more is to actually go here to the groups and pick the group you want to look at. You don't have to look at everything all at once. You can say, listen, I just want to look at the basic display parameters. That's going to give us 1 to 29. So there's not as much to look at. You're like, all right, I'm done with the basic display parameters. Let's look at the basic programming parameters. So, the basic things that I need to set up on a motor in order to get that thing to start. So here we can set up our motor voltages, our motor hertz, our overloads, acceleration times for acceleration time 1, start sources, how are we going to start this? These are the basic things that you need to set up for your motor. Then you're like, oh, listen, now it's time to wire the digital inputs, digital outputs. You can set all that stuff up here in the terminals section, right? So as you break down these groups, you're able to see more and more things in simpler chunks, which allow you to really not have to digest a ton of information all at once. So if we close down the parameters, basically this is the configuration page for the module properties for this Ethernet drive. So we'll get out of this and we'll just do one last thing to look at. Now that we've configured the drive as part of our I/O configuration, you'll see that the drive now exists in our controller tags. Now inside the controller tags, as we made that drive, we got some information, which is pretty handy for us. So you can see here that it's auto-created some tags. I'm just going to remove my face so that you can see those. And from here, we would actually be able to control the drive, right? So we have our PowerFlex 525 outputs. We have our PowerFlex 525 inputs. And we can actually make decisions based on the information that's here, right? So our outputs, we could actually send our start commands, right? So if this was a 1, we'd be able to send a start command, right? So when we sent that start command, you can see that the active drive turned on. We've got a commanded direction. The actual direction's turned on. We shut off the start command, but nothing changed. We have to enable the stop command, right? Then we have now a non-active, right? So now it has shut off. So we know that the drive itself has turned off. The advantage to this is we're not using any digital inputs. There's no wiring between my drives except for that Ethernet connection. We could actually command specific output frequencies, right? So if I say, listen, I want you to run at 50 hertz, I could put a value of 50,000 in there because this actual value of frequency command is done in 0.01 of a hertz. So now if I issue that start command, we're able to see the output frequency start to speed up. You shut the start command off, and you see the output frequency still is turning on until we issue the stop command. And now you can see the deceleration curve of the drive actually slowing down until it actually comes to a stop. So that's the basics of setting up a VFD over Ethernet IP, or more specifically, a PowerFlex 525 to a 5069 L306 ERM. We're able to actually have that VFD commanded and controlled from the PLC over the Ethernet protocol and able to do and configure a lot of that information. So if anybody has any questions, please shoot them into the chat. I'd be happy to answer those for you. We'll just stay online here for a little bit longer and see if anybody does have any questions, concerns. Again, if you were to add more VFDs to your network, you would just follow the same procedures, right? You'd add another module. You'd obviously give it a different name. That module would fall underneath that Ethernet IP communications protocol. And because it would have a different name, it would have a different tag structure. So if it'd be PF525_2, then it would just show PF525_2:O for your outputs or your inputs. So again, just like setting up communications between controller to controller, this is how you basically set up your communications, but how you write your ladder logic and how you control your devices are really up to you. There's no, there are some best practices out there, but ultimately it's about the functionality of the system. How do you make it work? How do you make that device actually talk? Guess one other thing we can talk about, well, I see if there's any questions coming up, is Connected Components Workshop or Workbench. So Connected Components Workbench is a cool software that allows you to do a lot of device configurations externally. You're going to see that when I go to Connected Components Workbench, it's going to look very, very similar to what we've had before. So I'm going to go to Discover because I'm going to be looking for a device on the network. When I go to Discover, it's going to show up a connection browser for me. I'm going to go to Ethernet IP because I know that's where my device is, find my PowerFlex drive, and hit OK. From Connected Components Workbench now, I pull up my actual drive information, right? So again, we've got our drive, we've got the device information, we have a parameters section where we can actually make our parameters adjustments, we have our faults area, device information. Again, we can run wizards from here. Very handy. We can actually do our addressing from here as well. There's lots of information that we can actually pull from this system. So a couple questions are coming in here, so I'm going to answer those as they come up. So one question, so can we use Studio 5000 to set up and commission all Ethernet IP to the drive instead of using BootP DHCP tool? You absolutely can. The key to setting them up that way is to set up and configure your IP addresses on the drive itself, right? So Studio 5000 has no way of pushing a IP address to the actual drive without having that drive set up. So you have to go through that manual configuration of using C128, C129, C130, 132, 133, all the way up to actually set your IP addresses up. But once you set that basic IP address structure with those 5 parameters on the manual screen on the VFD, after that, Studio 5000 can do all the commissioning and setup as you want. And that's the advantage. That's why a lot of automation technicians and control specialists, maintenance, skilled trades workers set it up manually on the actual VFD first, and then use Studio 5000 for all their configuration and commissioning. Once you've got it on the network, then you can do all of your stuff simply and much easier on the computer itself. Hopefully that answers your question. If not, please let me know. Next one is, can two VFDs be set up to communicate with each other directly, or does that have to be set up through a PLC? So you could set up two VFDs to communicate to each other using kind of digital input, digital output. If it was simple, listen, when I'm started, I want you to start. When you stop, I'll stop, or something simple logic, you could do that between two VFDs. There would be some relays because you wouldn't want a direct wire to each other. But generally speaking, you wouldn't want to have two VFDs kind of directly communicating to each other. You would want either some control system or some relay hardwired system actually set up to be able to do that communication for you. Typically, you would want some interface, some breakup between those two areas, rather than having any kind of direct wiring. So, hopefully that kind of answers that question as well. Let me know, and we can go into more details if we need to. So yeah, if you see here on the CCW, the Connected Components Workbench, there's a lot of really cool information that you can pull from there. So, it looks very, very similar, like I said before, to the way things were set up. You could do a data logger on here if you wanted to, which allows you to log information from the drive over an XY period. You can get your device definitions, right? What peripherals are attached to it. And obviously, in my case, I have no peripherals attached to it. You could add peripherals if you're adding devices to it. All that kind of stuff. So, Connected Components Workbench, I've used extensively when I'm actually doing some offline setup. So before I actually go to the field into a job, I will actually add devices to my project tree. So from here, you can go over, add a drive, add a 520 series, add a 525, pick the drive you want, right? That's the select. I'm going to select that drive, with, add that to the project. So now the drive's added to the project. I can select the revisions. I can actually go through and set up the entire drive without actually being online with anything. Set up all the parameters, blah, blah, blah. And then I can execute this program to extract the data. Once I extract the data, as I load up the drives themselves and type in the IP addresses, I can just come back here and actually download the information from this drive itself back into the actual setup. Typically, I've used that on stations that are 10, 15, 20, or 30 VFDs that I want to get the parameters set up ahead of time. If you're doing 1, 2, maybe 3 or 4, even up to 5, you could very easily set your parameters up as the commissioning tool, like was asked, on site as you go. You don't really have to do kind of that pre-engineering. But depending on your time frames and your project rollout, sometimes it's easier just to have that parameters and those setups done ahead of time. The other nice thing is in Connected Components Workbench, if you actually save this project with all of your drives set up and mapped, then you always have another database of backups available to you, which is pretty handy as well. So hopefully that was enough information for you. Hopefully that you have a better understanding of how to actually connect to drives to a PLC now. Relatively straightforward. We will go into a little bit of more details later on about how to actually program a drive, how to set those drives up. We may even talk about add-on profiles and how to add the add-on profiles into your software, because if you are doing a drive that maybe isn't an Allen Bradley drive or a drive that is normally defaulted into the actual software, you may have to add an add-on profile into the software so that your software understands what it is that you're doing, right? How are you actually getting that information in there? So we'll do that in a subsequent live stream. Just kind of hang out here for a little bit longer, see if anybody has any questions or concerns about what's going on. VFDs are definitely one of the more common motor control systems that are out there. They're getting very cheap right now. So you're going to see a lot more VFDs in industry. It's actually almost cheaper now to put a VFD in rather than to put a forward reversing motor starter with auxiliary contacts and all the other devices that are on there. It actually is becoming much cheaper for them to actually run a VFD. You also get more control, more data collection, that kind of stuff. So, okay, question just came in. What cable used to connect to read the drive from the PC when using Connected Components Workshop? So the nice thing with Connected Components Workshop is you do have the ability to do a few different things. The Allen Bradley PowerFlex 525 does only have Ethernet type connection. So we would, in this particular case, be using Ethernet protocol, right? So this here is the Ethernet IP connection, which has my drive. Other drives, not in the 525 series, may have a USB connection. So if there is the ability to have a USB connection, anything that exists in your RS links, you would be able to see in this connection browser. So for this case in the 525s, Ethernet IP is definitely the way to go. So that's how we have an Ethernet IP connection. We would use an Ethernet cable. This could be on plant LAN, could be on local machine LAN. It could be in any specific setup, but most of the time you're going to connect to a 525, a 523, a 527 over Ethernet on those drives. Now, as a caveat to that, the PowerFlex 525 behind the faceplate actually does have a USB connection, but it is very limited in what it can do. It's basically a USB data tool, which allows you to put the parameters into the drive by using just the USB connection on the back. You can't actually create or edit or do anything on the device itself. It doesn't actually power the device. It's only there for you to upload or download parameters if you want. It's a little bit not user-friendly, so I wouldn't necessarily say that that would be a good tool, but it is there for larger commissioning applications or different setups like that. So hopefully that answers that question about the cable use. Like I said, Ethernet cabling and Ethernet setup is definitely the easiest way to communicate to a VFD, and that's why I wanted to cover how to set that up. The basic setups of configuring the IP address on the drive, running it over Ethernet to the PLC to be able to pull that information in. One piece of information I think is pretty important. Once you set the IP address on your drive, you have to make sure that you cycle power. Cycling power on the drive allows it on boot to actually use that new IP address. So if you input your IP addresses on the drive itself and for whatever reason doesn't take that or doesn't seem like it's working, you can't communicate, just do a quick power cycle to make sure that the actual parameters got saved and were active when the drive itself boots up. All right, so wait a few more minutes here, see if any more questions pop in. Appreciate you guys coming and spending some time this morning learning about VFD to PLC communications or PowerFlex 525 to Compact Logix communications. Like I said, it's you find these almost everywhere now. They're very, very much a popular item in industry. So, all right. So on that note, I am going to end the stream here shortly. I will stay on and see if anybody has any questions. But as always, reach out to me, through any of the means that you have. If you have any questions, I'd be more than happy to answer them. So again, thank you very much for coming out and checking out the live stream today.